You, my dear students, today's as a part of the ELM that we are going to discuss about the apparent volume of the distribution, which is presented by Dr. R. Narayana Professor, Department of Pharmaceutical Regulatory Affairs, NJS Minister of Pharmaceutical Sciences, Mangalore. The learning objectives of this session is the apparent volume of a distribution. The apparent volume of the distribution is a drug in circulation distributes to the various organs and tissues. When the process of the distribution is complete, the different organs and the tissues contain varying concentrations of the drug, which can be determined by the volume of the tissues in which the drug is present. Since the different tissues have different concentrations of drug, the volume of the distribution cannot have a true physiological meaning. However, there exists a constant relationship between the concentration of the drug in plasma, where it's C, and the amount of the drug in the body, where it is X. V into C or X is equal VDC, where the VD proportionately constant having a unit volume and popularly called as apparent volume of the distribution. It is defined as the hypothetical volume of body fluid into which the drug is dissolved or distributed. It is called as apparent volume because all parts of the body equilibrated with the drug do not have equal concentration. Thus, from the equation, Vd is given by the ratio, that is, the apparent volume of the distribution is equal to the amount of the drug in the body, that is X divided by the plasma drug concentration C, where the Vd is equal to X divided by C. The table 1.1, the fluid compartment of a 70 kg adult. The fluid compartment of the 70 kg adult is given as the body fluid, vascular fluid, blood, that is plasma, volume is 6, percentage of body weight is 9, the percentage of TPW is 15, then extracellular fluid, the volume is 12, percentage body weight is 17, the percentage of the TPW is 28, the intracellular fluid, that is excluding the blood cells, where the volume is 24, percentage body weight is 34, and percentage TPW is 57. It leads to the total water, that is the TPW. The volume is 42, percentage body weight is 60, percentage of TW is 100. The volume of each of these real physiological compartments can be determined by the use of the specific concentration or the markers, which is reported in the table 1.2. The markers used to measure the volume of the real physiological compartment, that is the plasma, events blue, eucyanin green, and albumin. The apparent volume of the distribution is 3, and erythrocytes CR51, that is apparent volume of the distribution is 2. The extracellular fluids like non-metabolizable saccharide like napinose, insulin, mannitol, etc., where the apparent volume of the distribution is 15. The total body water is the DTO, HTO, and antipyrin is 42. Since the traces are not bound or negligible bound to plasma or a tissue proteins, their apparent volume of the distribution is same as their true volume of the distribution. The situation is different with most drugs which bind to plasma proteins or extracellular tissues or both. Certain generalization can be made regarding the apparent volume of the distribution of such drugs, where the drugs which bind selectively to plasma proteins or other blood components, example warfarin, that is, those are less bound to extravascular tissues, have apparent volume of the distribution smaller than their true volume of the distribution. The volume of the distribution of such drugs lies between the blood volume and the total TBW volume, that is between 6 to 42 liters. For example, the warfarin has a volume of the distribution of about 10 liters. Drugs which bind selectively to extravascular tissues, example chloroquine, that is, those that are less bound to blood components, have apparent volume of distribution larger than their real volume of distribution. The V of such drugs always greater than 42 liters or the TBW volume. For example, chloroquine has a volume of approximately 15,000 liters. Such drugs leave the body slowly and are generally more toxic than the drugs that do not distribute deeply into the body tissues. Thus, factors that produce an alteration in binding of drugs to blood components results in an increase in VA, and those that influence the drug binding to extravascular component result in a decreased in volume of distribution. Other factors that may influence the V are changes in the tissue perfusion and permeability, the changes in the physicochemical characteristics of the drug, example ionizations, the changes in the body weight and the age, and several disease states. Apparent volume of the distribution is expressed in liters and sometimes in liters per kg body weight. The VA of the various drugs ranges from as low as 3 liters to as high as 40,000 liters, much above the total body size. Many drugs have V are greater than 30 liters. The volume of the distribution is a characteristic of each drug under the normal conditions and is altered under the conditions that affect the distribution pattern of the drugs. The references for this ELM is the Shagel and Brahmankar textbooks. For additional references can be done. Thank you. Thank you very much.